Have you ever wondered about the current state of power systems and the dire need for grid-enhancing technologies? It's a question that has gained prominence in the energy sector. The world is in an era of rapid technological advancements, and our power systems are no exception. They are evolving, becoming smarter, more efficient, and more resilient. But with this evolution comes a paradox. The same technologies that empower us can also pose challenges to the stability and reliability of our power systems. That's where grid-enhancing technologies come into play. They are the superheroes of the power world, designed to maintain balance and ensure our lights stay on. Among these technologies we have dynamic line ratings, power flow control, topology optimization, and storage as transmission, each with its own strengths and weaknesses, its own pros and cons. So, are you ready for an electrifying journey? Let's dive into these technologies and explore their advantages and disadvantages. First up, we have dynamic line ratings, a technology that's changing the game. Dynamic line ratings, or DLRs, are a smart way of managing power lines. Traditional methods involve setting a static limit on the amount of power a line can carry. But with DLRs, these limits become flexible, adjusting in real time according to weather conditions. Now, imagine a cool, breezy day. The wind helps to cool the lines, allowing them to carry more power without overheating. This is where DLRs shine, leveraging such conditions to increase efficiency and maximize the power flow. However, it's not all sunshine and breezes. DLRs are heavily dependent on weather, making them less reliable during extreme conditions. Moreover, implementing DLRs requires significant investment in sensors and data analysis tools. Yet the potential impact on power system operations and planning is enormous. By making power lines more adaptable, we can improve grid reliability and efficiency. Despite a few drawbacks, dynamic line ratings offer a promising solution to improve grid reliability. Moving on, let's talk about power flow control and topology optimization. Power flow control is all about managing the direction and magnitude of power moving through the grid. This control allows for a more efficient use of existing infrastructure, reducing the need for costly upgrades or new installations. On the other hand, topology optimization is much like a game of chess. It involves strategically rearranging the grid to reroute power along less congested paths. It's like finding a quicker route to your destination when stuck in traffic. Both of these technologies have the potential to significantly increase grid stability. Power flow control can balance the load across different lines, preventing overloads and reducing the risk of blackouts. Meanwhile, topology optimization can adapt to changing conditions, ensuring that power finds the most efficient path even under unpredictable circumstances. However, like any technology, they are not without their challenges. The implementation costs can be high, and the complexity of managing these systems should not be underestimated. It's a bit like juggling. The more balls you have in the air, the harder it is to keep them all going. Yet these technologies could dramatically transform power system operations and planning. By optimizing the flow and distribution of power, we can make the most of our existing infrastructure and prepare for a future of increasing energy demand. While these technologies may require significant investment, the benefits they provide to grid efficiency cannot be ignored. Last but not least, we have storage as transmission. Now let's dive into this exciting concept. Storage as transmission is a novel approach to energy management where power storage devices are used not just to store energy, but also to aid in its transmission. It's a bit like having a relay runner in a race passing the baton, that's your power, down the line to ensure a smooth and efficient race, that's your transmission. One of the biggest pros of storage as transmission is the enhanced flexibility it brings to the grid. By storing power and releasing it when needed, it can help balance power supply and demand, mitigate congestion, and even improve power quality. It's like having a reserve army, ready to step in whenever there's a need. However, like all good things, storage as transmission comes with a few challenges. One of the major drawbacks is the high cost of storage technologies. Building and maintaining energy storage facilities can be quite expensive, which can affect the economic feasibility of this approach. But let's not forget the potential impact of storage as transmission on power system operations and planning. By providing an additional layer of flexibility and reliability, it can help utilities better manage their resources, optimize their operations, and plan for the future. Despite the challenges, storage as transmission holds great promise for the future of power systems. With these technologies, the future of power systems looks brighter than ever. Remember, dynamic line ratings offer us real-time data for better management. Power flow control and topology optimization allow for efficient use of our existing infrastructure. And storage as transmission? Well, that's our ticket to a more responsive and resilient grid. Together, these grid-enhancing technologies are the keys to unlocking a sustainable, reliable, and efficient power future. As we navigate the energy transition, these grid-enhancing technologies will undoubtedly play a pivotal role. Thank you for joining us on this electrifying journey into the future of power systems. We've taken a deep dive into the technologies that are shaping our world and our future. As we continue to explore and innovate, the potential for growth and improvement is limitless. From dynamic line ratings to power flow control to storage as transmission, we're on the cusp of an energy revolution. And you, dear viewer, are right here with us, witnessing the dawn of a new era in power systems. Remember, the future is bright, the future is efficient, and most importantly, the future is electric. Stay tuned for more deep dives into the technologies shaping our world and powering our future.